Today I'm going to go over in a little bit greater detail the process of brazing in the fire. Now, blacksmiths have been brazing in the fire for centuries, and it's ideally suited for assembling small parts that would otherwise be tedious or difficult to forge in any other manner. For example, this key was assembled out of three pieces. The bow, the shaft, and the actual bit of the key are three separate pieces that have all been brazed together in the fire. The key bit was assembled by chiseling a mortise into the shaft of the key, and then the flat bar that I used for the key bit was then inserted into that mortise, and then copper was melted into that recess to lock everything together. So the area that actually looks like rust where the bit meets the shaft of the key is actually the copper that I used to join these two pieces together. And basically the same process was used to assemble the bow of the key. The actual bow was made from a lock washer, and I cut a notch at the end of the shaft so that I could insert the lock washer into the shaft, and then again copper was melted into that joint. Brazing in the fire is identical to the process of soldering copper pipes together. To get the best results, you need to sand or grind away any scale or rust so that you have clean metal surfaces touching each other. Then you add the filler rod and set the whole thing in the fire. And then the whole assembly is heated up until the metal gets hot enough to melt the brass or the copper that you're using as a brazing material. And then at that point the metal flows into the joint through capillary action. And of course, if you have too much brazing material, then the excess will just drip off the metal into the fire. And at this point, the brazing metal is pretty much the same consistency as water, and it's going to react the same way. So if the piece is sitting fairly level in the fire, it'll drip evenly around the edges. But if it's tilted to one side, it will drip off, that one edge. So that's something that you need to consider when you're designing the pieces that need to be brazed together. To make a neater and more controlled brazed joint, the process of tinning was often used. Tinning involves coating one piece of the metal with the brass or the copper that you're using, and then you cool that piece and then mechanically grind or sand away any of the material that you don't want. So now when you assemble the two pieces and get them ready to go in the fire, the thin layer of brass is already bonded to one of the pieces, and it's cut exactly to the footprint of the other pieces, so there's no excess to flow anywhere. So when you apply the heat, the two pieces just get bonded together, and in theory there shouldn't be any excess material to flow anywhere. So that's the theory. Hopefully this will give you an idea of how it actually looks in the fire. What you're looking at is just a square bar that's bent back onto itself, and sitting on top of the square bar I have a coil of copper wire. You can use a brazing rod or copper. It really doesn't make that much difference. It's basically a soldering process. So the strength of the material that you're using is going to determine the strength of the joint. And I don't think that there's that much difference between brass and copper, in terms of tensile strength. So either one produces, basically the same results. Copper wire is just so much easier to keep on hand than brass rods, so that's why I use it, and I've never had any trouble with it, even though the tensile strengths are slightly different. As I mentioned earlier, brazing in the fire works better on smaller pieces, and that's mainly because you need to get the piece right into the fire to generate the heat that you need. In my first attempt at filming this, I thought a large flat plate sitting on the fire would work well because it would hide the fire and allow the camera to adjust to the actual process, but I could not generate the heat to melt the copper wire. I had a raging inferno going underneath this plate, but the top side was staying cool enough from the draft going into the chimney that I just could not generate the heat. So you need to be able to get the piece in the fire. So here we are back to our sample piece, and I start applying flux as soon as the metal is hot enough to melt the flux and have it adhere to the surface. I'm just using 20 mule team borax, the same thing I use for when I'm forge welding, and it's just a detergent, aisle borax. There's nothing special about it. And even though this is a powder, there's a fairly high moisture content, so when you first apply it, it's going to bubble and boil off all of that moisture. And eventually it's going to boil down into a very thin glass-like liquid that's going to coat the entire surface and prevent any scale from forming. The next process happens fairly quickly. Copper goes from a solid to a liquid without going through any kind of a softening stage. So it'll be a wire 1 minute and then it'll just dissolve into a liquid. But just before that happens, the surface takes on kind of an oily, iridescent look to it. Here I have it slowed down quite a bit, so this minute-long clip actually takes place over about 10 or 15 seconds. Here you can see how just a few degrees makes quite a difference when you're trying to get this melted. The bottom half has already gone because it's tilted downwards slightly in the fire, so it's a little hotter. In a second here I'll be moving the part that hasn't melted down just a little bit, and as soon as I touch it, it'll just dissolve. So here's a close-up of the piece out of the fire. I didn't bother grinding off any of the fire scale on this piece, so you can see how patchy the brazing is. The borax was able to clean off some of the scale, but not all of it, so the copper just flowed in a very erratic pattern. And you can see how the copper just clings to the surface. It doesn't fill any large voids. So on the right you have the gap that is filled with copper because the gap is small enough and the surface tension will keep the copper in place. And on the left there's a film of copper around the outside, but there's nothing in the middle because that hole goes right through the piece. There's nothing to stop the copper from just flowing right through. Copper will fill a blind hole, but if it goes right through the piece, it's just going to flow right through to the other side. So to have a good solid brazed joint, you need to have fairly close fitting parts that are clean and free of any fire scale. The molten copper will not fill any large gaps or spaces between the parts. Hi, I'm Dennis and thanks for watching. As most of you know, for the past few years I've been producing YouTube videos on a part-time basis. I am now looking to turn that hobby into a full-time job, and for that I really need your help. A small monthly contribution from a really small number of viewers will generate the income that I need to achieve that goal. So if you're interested in the work that I'm doing and you want to lend your support, please click on the Patreon icon at the bottom of the screen. Thank you. We'll see you next time.